As we discovered in the first episode, the incredible advancements in electricity are thanks to the combined efforts of numerous scientists, engineers and inventors throughout history. One built on the work of others to bring us the powerful technology we use these days. In our today's episode, we will be talking about Luigi Galvani, Alessandro Volta and Michael Faraday. Welcome to Personality Matters, the channel where we explore how people impacted the world. If you like the content, subscribe to the channel and hit the notification bell. Luigi Galvani conducted lots of experiments with dissected frog legs. These experiments laid the foundation for the concept of galvanism. In simple terms, it refers to generating electrical activity in living tissue. Galvani noticed that frog leg muscles twitched when given an electric shock, even if they were not attached to the frog's body. This showed that living things had their own natural electricity. Galvani's experiments with frog legs and metals helped inspire the creation of early batteries. By studying how different metals affected frog legs, he set the stage for Alessandro Volta to invent the first electric battery. As you might have guessed, Alessandro Volta's most famous achievement was the creation of the electric battery, which gave us a steady source of continuous electrical current. Volta made a battery called the voltaic pile, using layers of zinc and copper, separated by cardboard soaked in salt water or acid. When he connected the top and bottom of the pile with wires, a steady electric current flowed. This invention was groundbreaking because it showed that electricity could be made through chemical reactions, not just by static electricity from friction. It revolutionized the study and use of electricity, leading to many technological advances, such as the telegraph and electric motors. Michael Faraday is another great scientist who made some important discoveries in the field of electricity. His most famous discovery, made in 1831, is electromagnetic induction. Imagine this: you have a wire and a magnet. If the magnet just sits next to the wire, nothing happens. But Faraday discovered something amazing. When you move the magnet near the wire or move the wire near the magnet, it creates electricity in the wire. This discovery is incredibly important because it's the basic principle behind how most electricity is generated today. In a power plant, giant magnets are moved near coils of wire, and this movement creates electricity flowing through those wires. This electricity then powers our homes, lights, computers and everything else that needs electricity to work. The movement of electric charges is what we call electricity. Also, Faraday formulated two laws of electrolysis in 1833, which describe how electric currents interact with chemical substances. First, let's explain what electrolysis is. It's a process that uses electricity to break down a substance into its basic parts. Through numerous experiments, Faraday discovered two fundamental principles of electricity in chemistry, which were eventually named in his honor: Faraday's first law and Faraday's second law. Faraday's first law stipulates that the more electricity we pass through a substance, the more we get out of it. Think of it like a candy machine. The more you push the button, the more candies you get. So if you're making different kinds of candies, you will get more the heavy ones and fewer of the light ones. Basically, Faraday figured out that the amount of things you get depends on how heavy they are. So if you're making chocolates and cotton candies with your magic machine, you will get more chocolates and fewer cotton candies because chocolates weigh more. Thank you for watching this episode. Don't miss the third part on the key figures in the history of electricity.